Okay, so first we are going to discuss about input. So what is input and what is output? Any signal or any information, if we are going to read, that is input. So how to read any signal from microcontroller, and after that how we can give output signal from the microcontroller for controlling any appliance. So how we can do that kind of activity, that we are just going to discuss over here. So these are input examples like push button, switch, light sensor, flex sensor, humidity sensor, and temperature sensor. With the help of that, we can read any signal. And after that, there are few examples. These examples are about output, like we can give output to DC motor, LED, servo motor, and we can control any pump, or we can control RGB LED. These are output examples. So there are two, three things that is very important to understand about read and write. So first of all, we are going to discuss about analog and digital. In previous class also, I have discussed that what is analog signal and what is digital signal. But over here, you can see these are 0 to 5 years showing over here. These are digital signal, high and then low, then high, then low. These are digital signal, and analog signal look like this. So how we can read analog and digital signal in microcontroller, that is very important. So these are a few example of Arduino and Arduino compatible boards. So there are many Arduino boards. You can opt according to your need, that which one you want to use for which applications. So as I'm going to show over here, this one is Arduino Uno, that is customized board built by SparkFun, and this one is very interesting board. This one is LilyPad and this one is Mini LilyPad. So these boards are used in cloth. If you want to mount any circuit in cloth, then that can be mounted with the help of LilyPad. Like I'm just giving you one example. Like if you want to build a device for maintaining social distancing, for that you can build a device using ultrasonic sensor, and you can use this small microcontroller and you can mount in your cloth. With the help of that, if any object, any person coming closer to your threshold distance, then it will be given you a warning that someone is coming closer to you and avoiding your social distancing and breaking your social distancing law. So that can be done with the help of these sensor. So anything you want to build with the help of microcontroller and want to deploy that project in cloth or in flexible thing, then you can use this LilyPad. So in LilyPad, how to write a program that is very similar to Arduino. So that I will let you know. This one is Arduino Mini. You can use it for your application. Arduino Mini or Arduino Nano, we can call it. But working of this Arduino Nano is similar to Arduino Uno, but you can directly deploy it in your project so that your cost can be reduced, as well as you can directly solder it in your circuit or in your PCB board. So after that, these are also similar to Arduino Mini. You can use this one also, and this one is Arduino Duo. Arduino Duo, what application of Arduino Duo? It's having high processing power. If we talk about technical little bit, Arduino Uno is having frequency of 16 megahertz. Frequency of 16 megahertz, but Arduino Duo is having frequency of 85 megahertz. It's approximate 4 times than Arduino Uno. So if you want to use and want to deploy in any project related to like MATLAB, if you are building some model in MATLAB or in Simulink and you want want to deploy directly from the MATLAB, then you can use this Arduino Duo for any research application or any advanced application. This one is best option for high processing power. Similar way, this one is 8085. This microcontroller name is 8085. You can note it down so that you can purchase it in a very less cost, and you can guide your student that you can build any project using this 8085, and your project cost will get reduced so much. And similar way, you can also build some product also with the help of this 8085 microcontroller. So how to do programming in this and how you can do interfacing of this 8085, that I will let you know in upcoming session, as well as few things I'm going to discuss today also. So these are few microcontrollers from low cost to higher cost, from low processing power to high processing power, from low less number of pin to high number of pin. So in similar way, you can use according to your applications. So again, I'm just going to discuss about few big six concept for the programming. So if you are familiar about these six steps, then you can easily interface your circuit and you can easily write your program whatever you want to do. So what are these important six steps and how to use it? So that I'm just going to discuss over here. Like digital write, this one is a function that is being used in the programming of the Arduino. These are embedded C function. So what's the difference between C and embedded C? C is a simple C language, but in embedded C, few dedicated function is being embedded in C language, and with the help of that, we can write program easily to the hardware. We can deploy a program in the hardware in a very simple manner. So, and these six functions we can use, and we can build any kind of project with the help of these simple functions. So let's understand that how we can use these functions for our applications. First of all, we are going to understand digital write, and then analog write, then digital read, then if statement and boolean, then analog read, then serial communication. So how each and every step, every function I'm going to elaborate in with the example of practical example, so that you will get more familiarity about it. So let's get started. So how our program will be executed in microcontroller, like we want to turn on LED, then we want to put wait, then LED off, then wait, then rinse and repeat. So yesterday we made one example of LED blinking. That same example will work like this, and then at the end we are going to repeat it. This one is physical computing, we can call it. So these frequencies are very important. I'm going to discuss it a little bit earlier. You can note it down, and you can also take screenshot from your PC, and how you can use these frequencies. These frequencies are sa re ga ma pa dha ni sa. So these are notes, and we are going to build one piano with the help of this frequency. That if you want to build a piano using microcontroller, that also you can build. So that I'm just going to discuss in practical session, that we are going to start in upcoming few slides after completing this slide. So first of all, we are just going to discuss about little programming, that what is structure. Structure is a structure divided in three main parts, like structure, like function, loop. As I shown in the example, that in Arduino there are two things in minimal program. There is one void setup and void loop. So in void setup we have to initialize pin. So these are part of structure, like setup and loop. And setup is a function that is inbuilt in microcontroller Arduino, and loop is also a function. like void. Void mean anything, any function we are writing, then there will be no return. Any value will not return back in any void function. So we will discuss in detail that how we have to write a program, but before that we are going to discuss about programming and how we can use these programming for our applications. So I'm just going back to Tinkercad, and over there I will give you a little bit more detailed demo that how you can use Tinkercad. Audio is very low. I'm just going to increase, going to speak a little bit louder, so no need to worry about it. So is it audible right now? My voice is audible. Kindly respond in the comment box. Okay, that's great. Thank you. So now, if someone is having issue with the voice, kindly check their mic and their speaker so that their voice issue can be resolved. Okay, so we are going back to Tinkercad, and over there we are going to use Tinkercad, yes. So in Tinkercad, what we have to do, first of all, we have to do sign up. So how we can do sign up? That is very simple. Just go to join, or if you have created account, just do sign in. You can sign in with your mail ID, or you can sign in with your Google account also. So I'm going to sign in with my mail ID, and similar way you can do it. If you have created account over here, then you can type your password. Yes, I did my sign up process. Okay, now after doing sign up, what we have to do, your Tinkercad will get opened, and some of participants were asking that we did sign up, and we are facing issue in design, that they are getting direct design. So what you have to do after doing sign up, go to circuit over here. Again I'm repeating, go to circuit over here and click in the circuit part. Then you will able to do. If you are not able to see this screen, then go to this home screen again, and then you will able to find this screen. And initially you will be by default in design, so you have to click on circuit. Then you will able to access your circuit. Yes. Now after going in circuit, you have to create new circuit. So how you can create new circuit? Click over here, create new circuit. Your circuit will be get created automatically. Okay, as your circuit will created, mean your new circuit dashboard will get opened. So how you can build circuit over here, that yesterday I have shown, and today we are going to give you a few assignment, and that assignment is based on Tinkercad, and you have to create circuit in the Tinkercad, and you have to submit assignment with a screenshot. So what you have to create, so I'm just going to give you few example that is being part of your assignment. So if you are going to use breadboard, how to use it, and I'm going to connect LEDs in series and parallel. So I'm going to make a LED series connection. So I'm going to connect 3 LEDs over here like this. Yes. Yes. Might be few participants did lot of practice in the Tinkercad. It's very interesting tool, so you will enjoy it, and also your kids will enjoy it if they will make something over here. They will design something. So after that, I'm going to connect one resistance with this. So each, if all LEDs are in series, then you have to connect like this. Positive should be connected with negative, and negative should be connected with positive. And at the end, this one is anode positive, and this one is cathode negative. So I'm going to connect resistance with positive. You can connect with negative or positive anywhere, because your circuit resistance should be in your circuit closed loop anywhere in this series. So I'm going to make connection like this one is ground, this one is positive. Yes, sorry, I have to connect it over here. Now I have to connect battery. So there are many batteries. I'm just taking this battery. So why I'm taking this one? Because you can use it further for your applications. Like this one is 1.5 volt battery. If you want to increase that battery voltage, how you can do it? You have to connect battery in this series. So I'm going to increase the number of battery, like 3 battery. I'm going to connect 4 battery I can connect. So I'm going to connect 3 battery. So total voltage will be 1.5 plus 1.5 plus 1.5, 4.5. Mean whenever we are going to connect batteries in series, then voltage will get increased, voltage will get added, and current will be same. So I'm going to connect negative to my battery, my circuit negative, and positive to. Before going to connect positive, I'm going to use this switch, so that I can use switch whenever I want to run it. So I connect it like this, and this one should goes to over here. Yes, my circuit is complete. Now I'm going to run my circuit. So let's see. I'm going to run simulation. I think screen is being shared. It is visible to everyone. Now sound is okay, or there is echo? Okay, okay. Thank you. Thank you. So it's good that participants are maintaining patience, and they are not putting any extra comment for avoiding any kind of disturbance. So it's very good, and thank you so much. So now I'm going to run simulation. Start simulation. So simulation is get started, but LEDs are not working. Yes, LED is working. As I'm going to switch on, LED is working, but brightness is very less. For that, what I have to do, I have to calculate proper resistance value for LEDs in series. So how we can write, what will be the formula for that? I'm just going to show you the formula for that. So what will be the formula? V minus Vf, that is your forward voltage for LED, is equal to I into R. So IF will be your forward voltage, that is being into R. So if you have to calculate resistance value with when LEDs are in series, this one is for one LEDs. When LEDs are in series, then you have to multiply with N. So N I'm going to multiply over here. Okay, N represent number of LEDs. Mean I'm going to give you one assignment right now. You can solve it. That we are going to connect 3 LEDs over here, and supply voltage. This one is supply voltage. So V supply is 4.5 volt, and LED voltage forward voltage is 2 volt, and IF mean forward LED current, that is 20 milliampere. So now you have to calculate resistance value, and tell me in the comment box that what would be the exact resistance value according to your calculation. I have written formula over here, so nothing big. So V supply I have given over, that is equal to 4.5 volt, 4.5 volt, and Vf is equal to 2 volt. So sum is If is 20 milliampere, If is 20 milliampere, and R you have to calculate. So N is number of LED. Number of LED means 3 LED you are going to connect over here. So 75 you are saying Vf mean forward voltage. Yes, LED forward voltage, that is 2 volt. So Vf is 2 volt. 2 volt. So if you are saying 125 ohm, if you are saying 75, so let's check it that how much it is. I'm going to first erase it. Yes. Okay. So if you are saying that, yes. So let's see. Let's put it 75 first and see that what is happening. Or just suppose that I'm just taking it 1 ohm. So I'm just running it. Start. Sorry, I have to change it for 1 ohm. How can you change it? For that you have to click on this resistance like this, and you have to change kilo ohm to ohm. Ohm is unit of a resistance, so I'm just taking it 1 ohm and then see what is happening. So LED is working with 1 ohm also. So what is happening over here? So why this one is happening? So what is error over here? Yes, someone has given a very good answer over here, because we are using 3 LED mean for glowing 3 LED we required 6 volt minimal, because 2 volt drop across one LED, 2 volt drop across second LED, and 2 volt drop across third LED means 6 volt, but our supply voltage is 1.5 volt. So when you going to calculate resistance value, that value will be in negative. So there will be no negative value in the resistance, or there is no negative resistance. So you have to make your understanding in a very simple way, that if you have to glow more LEDs, then you have to provide more supply. So you have to check with your formula and your calculation. So for that, what we have to do, we have to increase batteries. So I just did over here. So now my battery voltage is 1.5, 3, 4.5 or 6 volt. So now my LED is working fine with 1 ohm resistor, or if I will not connect this resistance, then also my LED will work fine. To check voltage of your battery, what you have to do, you have to connect multimeter. So how you can connect multimeter? Just search over here, or you will find that connect multimeter and check voltage, how much supply voltage is from the battery. So the negative I can just, yes, correct. Yes, correct. So after connecting multimeter, check over here 5.98. So it's approximately 6 volt, because there is little drop in voltage due to load. So why it is happening, that I will let you know in upcoming practicals. Okay, so you can make similar kind of parallel circuit, that is part of your assignment, that I'm just not going to discuss over here. So what formula you have to use, that you have to find and you have to calculate. Yes, we can also add 9 volt battery. I'm just going to add 9 volt battery. So how you can add 9 volt battery? For that, find 9 volt battery and you can connect it. Yes, this one is negative and positive should be directly connected over here. Now I'm going to run it. This one is negative. This one I'm going to delete it. Positive, yes. So you can check it. So 8.79 some voltage drop is over there and LED is being get damaged. So now for 9 volts, so kindly calculate resistance value for 9 volt and tell me so that I can put that value. So formula you are having. So someone is saying 1 kilo ohm. That is wrong answer. So it's not that we have to not put direct heat and trial. We have to calculate with formula. So that is not universal that you have to use 1 kilo ohm, because when you are going to use going to build any product, then precisely you have to calculate. Yes, someone has given answer 150, so 150 LED is working fine. So you have to optimize resistance value so that there should be no power loss, as well as your life of LED should be good. So if LED consuming more current and overload it, then your life of LED will get reduced. You can also use 1 kilo ohm, but your brightness will not come out that properly brightness. Or if you want to change LED color, that also you can do. Change color orange, and then I'm going to make it blue. Yes. So you can also change color from over here by clicking on the LED. Okay, very good. So all participants are responding in a very good way. Thank you so much. So again, now I'm going to use one more applications of connecting resistance over here. So the very important concept that I'm going to discuss over here, that is about resistance. So you have to understand it in very careful way so that you can utilize it for your applications. So how to use it? So I'm just going to discuss with you one concept, that is voltage divider rule. So what is voltage divider rule, that I'm just going to discuss with you. So how you can use that voltage divider rule for your applications. That voltage divider rule is using for dividing voltage, but maximum resistive type sensor is used with the help of voltage divider rule. So whenever we are going to connect any kind of resistive type sensor, then we have to use voltage divider formula and voltage divider rule, and we have to apply it. Then only we will able to make a circuit for a sensor. And 70% sensor are resistive type. So if you want to interface any resistive type sensor, then you have to build voltage divider rule, and you have to understand it, that how it is being working. So now I'm just going to discuss with you that how you can use voltage divider circuit and how you can make it. So I'm going to connect one resistor over here, and after connecting resistance, you have to connect one more resistance. So don't look towards my drawing. So I'm going to connect one battery over here. The battery voltage can be any 9 volt or 5 volt. So I'm just taking it 5 volt, or we can write it V supply. V supply. So this one resistor is R1. This one resistor is R2. So how to divide a voltage? Whenever we have to divide a voltage, we have to connect two resistance and we have to take output from over here. So I'm going to take output from over here, that is V output, and that output we are measuring across ground. Mean whenever we have to measure voltage, we have to connect one terminal to the ground, that reference ground, and we have to measure, we have to connect the positive probe at the middle of over here. So we are getting output. So R1 and R2, two constant resistor I'm using over here. So what will be the formula for voltage divider rule for output voltage? If we have to get exact output voltage, so how we can design a circuit according to our application? So formula will be supply, that how much supply voltage we are giving, multiply R2, the resistance across which we are going to measure voltage, divide by R1 plus R2, sum of total resistance, divided by R1 plus R2. So note it down, this formula, that is very helpful. Yes. So this one is voltage divider rule. You can use it any kind of resistive sensor. How we can use it, that we are going to discuss today. So that is very interesting. So how we can use it? So I'm giving you one example. Like we are using 5 volt supply, and this one resistor is 1 kilo ohm, and this one is also 1 kilo ohm. So what will be the output voltage? Kindly respond me with comment that what will be the output voltage when we are giving supply 5 volt and voltage 2.5 volt. Very good answer. So output voltage will be 2.5 volt. Okay. Again, I'm just going to change few value of resistance. Going to increase this resistance. Mean this one resistance is 10 kilo ohm, and this one also 10 kilo ohm. What would be the output voltage? Again repeating. This one is 10 kilo ohm, R1 is 10 kilo ohm, and R2 is also 10 kilo ohm. Yes, then also it will be same 2.5 volt. So I'm going to do some more change. So this one is 1 ohm and R2 is also 1 ohm. What would be the output voltage? So everyone is saying same. Very good, very good. And again, I'm just making it. This one is 1 mega ohm, and this one is also 1 mega ohm. What would be output voltage? Same. Very good. Now we are going to check it in circuit, and then I will show you it will be not same. So why it will be not same? Because in your calculation it is correct. You are saying 2.5 volt, it is correct. But whenever we are going to implement it in a circuit, in a hardware, then output will be something different. So how it will happen? What will be the reason behind that? That we are going to discuss right now. Yeah, a lot of things can be over there. So why it will not be same, and what should we have to connect? So I'm going back to Tinkercad, and then we will discuss that how we can use it. Yes. So we are going to make a voltage divider circuit over here. You can delete from directly over here, or you can by clicking any component, or directly you can use your delete button in your keypad. With the help also you can delete any component over here. So I'm going to build a voltage divider circuit over here. For that I'm going to connect two resistance. So I connected one resistor over here, second resistor. If you want to rotate your component, so how you can rotate your component, that I'm just going to discuss over here. Like this you can rotate it. Yes, I'm just putting it over here. Yes, I'm rotating this component also, so that you will get familiar about the circuit that I built it over here, over in the whiteboard, and same circuit I'm going to use over here. Yes, I connected it, and now I'm going to connect it with ground. I'm going to take, sorry, this one should be connected. Yes. So from here we are going to take output. Output I'm going to connect over here so that I can measure it in a very simple way. Yes, this one is output. So output, how I can check? I have to use multimeter. Yes, you can take multimeter so that you can measure output. Negative should goes to ground, and positive should be goes to over here. And this negative should be connected with ground, because all ground should be common. Now we have to connect battery. So I'm going to connect one battery of 9 volt, or you can take any 5 volt battery also. 9 volt battery, positive should be connected with positive, and negative should be connected with negative. Yes, my circuit is complete now. The same circuit I made in the whiteboard, that same circuit I have created over here. Two resistor, this one is R2 and this resistor is R1. Both are having now how much value? Can you tell in the comment box? Can you tell this resistance value? So I'm waiting for your comment. You can write in the comment box with this color code. Color code is red, brown, red, black, and brown. What would be the value of resistance with this color code? So you can calculate color code using BB Roy Great Britain with that formula, that concept. Or if you don't remember that formula, or you don't remember color code, just directly click over here and then see that the value of that color code you are getting over here. If you want to make it 10 kilo ohm, then this one will be orange. If you want to change it, then the same color code will get automatically reflected over here, whatever value you will put in the resistance box. So that also you can do. There is some connectivity issue, I think. Is my voice audible? Okay, yeah, great. So you can calculate it accordingly. Yes, again I'm going to share with you circuit. Okay. Yes, so over here what you can do, yes, so in this circuit you can calculate resistance value. 4.5 answer is wrong, sorry, voltage if you are saying. So I'm just talking about a simple resistance value with the color code. If the color code is, I'm just typing in the comment box, red, brown, what would be the value of that resistance? Red, brown color code I have just typed. Yes, the value of that resistor is 220 ohm. Red, brown. Yes. Okay. So after that, if we created circuit over here, so I'm just going to put that value that we have calculated over there. So I'm going to make it 1 ohm. How much? 1 ohm. I'm going to take it 1 ohm, and second resistor value is 1 ohm. So output should be, how much will be the output when both resistor is 1 ohm and supply voltage is 9 volt? So what would be the output voltage? So I have connected this resistor 1 ohm and 1 ohm, both resistors are towards answer 1.5. Output is coming. See it. It's showing 2.57 volt. Now you can see output. Output is coming 2.5. 2.57. Can you see it? Yes, great. So why it is happening, that is very important. That I told you, according to formula R1 and R2 we have connected, and we have given 9 volt supply, and both resistance value is same. R1 is equal to R2 according to voltage divider rule formula. Then it should be 4.5 volt, but now it coming 2.57. Similar way, I'm just going to increase this value to 100 mega ohm, and similarly I'm going to make it second one also 100 mega ohm. So both resistance value I have just taken equal, mega ohm and mega ohm, 100 mega ohm, both resistor are equal, and now output is coming 3 volt, but it should be 4.5 volt according to our formula. So why it is happening, that is very important. Listen carefully, that whenever we are going to connect too much large resistance, then very small amount of current is flowing in the circuit. Very less minimum current is flowing in the circuit, and voltage is not being divided properly. And similar way, whenever we are going to connect very less resistance, then very high current is flowing in the circuit. Due to that high current, battery voltage get dropped. जैसे कि sometime it happen in our home also, whenever we are going to start a high power rating motor, then supply voltage get dropped due to high load over there at the end. Similar way, that same application, same thing is happening over here. Whenever the resistance value is very less, then voltage current is flowing too much high in the circuit and voltage get dropped in the battery. So you, if you want to check battery voltage also, then you will find there will be some drop in the battery voltage. So I'm going to use to check that what battery voltage with multimeter. So again, I'm going to connect one more multimeter to check my supply voltage. I'm going to connect it ground and going to connect it positive. So this one is 9 volt is coming because I have connected high amount of resistance. So there will be no voltage drop, but current will flow in the circuit is very small. So the voltage dividing is not took place. So I'm just going to reduce it in 1 ohm so that you can check it out that how it is affecting your circuit. And this is the advanced simulations. Whatever you want to make, you can simulate it and verify it over here without having any kind of component. So I'm just making it to 1 ohm. Yes, now you can see output is coming 2.57 and supply voltage get dropped because the resistance value is very less and circuit become look like a short circuit and battery voltage get dropped and you will not get proper output voltage. So whenever you are going to use voltage divider rule in any sensor or any microcontroller for reading or dividing voltage, then what would be the optimum value of resistance? So for that you have to use 1 kilo ohm to 10 kilo ohm resistance. How much? 1 kilo ohm to 1 kilo ohm to 10 kilo ohm is optimum resistance range for a voltage divider circuit for using in any sensor or using microcontroller analog voltage reading purpose. So that is very important concept. So now we are going to use this concept over here. I'm going to repeat it again. If we have to use voltage divider circuit for any kind of sensor application, then we have to use 1 kilo ohm to 10 kilo ohm range of resistance, that is optimum, because with the help of that your current loss will be minimal and you will get proper accurate output voltage. Because if you are going to connect very less resistance value, then your battery consumption will be higher in your circuit and your circuit will be not optimum. And if you are using very high amount of resistance, then you will not get proper voltage at the output and your circuit will not work efficiently. Sensitivity of your voltage divider will get reduced. So hope you got it. There is no any other formula to find it in a correct way. That is practical scenario. Whenever you are working in a circuit in a hardware in an industry, then you will realize this thing and you will calculate exact value that is desired. So few things we study in books, but few things you cannot learn with the help of books. For that you have to learn, you have to do practical and you have to spend more time in hardware, then only you will get understood about few practical concepts. So over here I'm just going to use these voltage divider rule for a circuit application. So I'm going to use a LDR circuit and how you can use LDR in a microcontroller, because first of all we have to understand LDR means what. So I'm going to take it over here. So there is some disconnectivity. Okay, so I'm going to take it over here. One LDR sensor. So this one is LDR sensor. So how it is working, I'm going to show over here. This one is LDR. Are you able to see LDR? Let me see it again. Class is disconnected. Now class is working. Yes, great. Great. Due to internet disconnected, it happened. Sorry for interruption. So again, I'm coming to circuit. So we are using LDR. So this one is a LDR, mean light dependent resistor, or we can also call it as a photoresistor. So how we can use this photoresistor for our applications, that we are going to discuss. So in LDR, how it is working, I'm just going to run a simulation of LDR. This one is LDR. LDR means whenever light is falling on the LDR, the resistance value of LDR is increased or decreased. That change is happened in the LDR sensor with the help of light effect, so that we can measure light intensity, light lux value with the help of LDR. So there are plenty of application of this LDR. You will find this LDR in night vision camera also. You can find this LDR in automatic street light also. You can find this LDR in solar light also. There are plenty of application of this LDR sensor. So how we have to use this LDR in a circuit, and how we can read this value in microcontroller, that we are just going to discuss over here. So how resistance value is changing in LDR, I'm just going to measure over here the resistance value of this LDR. For that, I'm going to connect multimeter with LDR. So if you want to measure resistance in a circuit, or sorry, in any component, so how you can measure? For that, you have to connect this multimeter like this and click over here in R. So this one is 180 kilo ohm. This one is a full darkness. We are going to increase light intensity in LDR, the resistance value is decreasing. So the range is 506 to 180 kilo ohm. That is range of resistance. But the important concept is over here, that we cannot read directly resistance value in microcontroller. So how we will read it, that is question. So how you can read it, that is very important point. That for reading resistance value in microcontroller, for we have to convert this resistance value in a voltage signal, and microcontroller can understand in the language of voltage signal. So over there we don't need too much power. We just need a voltage signal that can be vary according to sensor value, according to sensor property, so that we can measure that deflection in the sensor in the format of voltage. So how we can measure voltage when we are going to change this resistance value? So let's use this resistance in this voltage divider. I'm not going to do anything. I'm just going to change this resistance in a variable resistance. So for that, I'm going to delete this resistance and going to connect this resistance in replacement of R1. I just did one thing only. So after doing it, let's see how output voltage is varying according to this resistance. And second resistance, as I told you, it should be in the range of 1 kilo ohm or 10 kilo ohm. So I'm just going to use 1 kilo ohm resistance, that is R2, and this one is R1. That this one is changing from 180 ohm to 850 kilo ohm. So kindly, whatever I'm going to tell over here, kindly make a note so that you can solve your quiz. Otherwise you will face a lot of difficulty, and that kind of thing you will not find in any book, or sometime you will not find in Google also. So you have to be attentive, and you have to make notes so that you can solve your quiz. So now your quiz is going to become more tougher and tougher, and that is based on fully practical things, whatever you are going to learn in the hands-on session. Okay, so I'm going to run it and check it out that how my voltage is changing. So I have not used any microcontroller over here. I'm just going to use a single LDR over here and going to make a circuit of LDR. So any sensor you can use it like this in your circuit, and you can test your circuit, and you can test your sensor also that it is working or not. Sometime whenever we are going to make a circuit, and whenever our project is not working, then we are not able to find is that where is the error. So we can check each and every component in the Tinkercad, and then you can identify that where is fault and where how we can resolve it. So I'm going to change this light intensity, and you can see what is happening. Voltage is changing. So voltage is changing. The range is different because the range depend upon R1 and R2 value, because both R1 and R2 value is different. So you will not get exact half voltage. That was due to R1 and R2 were equal over there that we have discussed. Now we are changing R1. So output voltage is changing. So that deflection we can measure in the microcontroller. So for that, the important point that I'm going to discuss over here, that whenever we are going to increase this voltage 5.97 over here, so we are getting output 5.97. But the important point is there, the whenever we are going to connect Arduino microcontroller work at the logic of 5 volt. And if we are providing power more than 5 volt, then our microcontroller will get damaged. So that is very important concept, that you have to provide maximum 5 volt to your microcontroller. If you are going to connect any sensor and those sensor giving output more than 5 volt, then your Arduino will get damaged. So that is very important. So if we are going to connect this sensor with the Arduino, for that we have to connect over here 5 volt. So supply should be 5 volt. So now I'm going to use Arduino over here. Yes. And going to use this sensor with Arduino. So how just going to show, make fit to screen if it's bigger or small. Yes. So for that you have to provide 5 volt to the sensor. So how you can give 5 volt from the Arduino? This one is 5 volt. So you can directly give 5 volt to your circuit from over here and ground to ground. Yes. So I have connected ground and 5 volt supply. Now I have to check that how much output voltage is coming. Let's see. Start simulation. Till now I have not did any coding part. So as I'm running simulation, let's see how much voltage is coming. 27.7 millivolt. I'm just changing it. Yes, voltage is changing with LDR brightness or LDR light intensity. Yes, so mean we are getting output not more than 5 volt, because we have supplied maximum 5 volt over here. So we supply 5 volt. According to our circuit, we cannot get more than 5 volt more than supply voltage, because we are using resistor over here. So voltage will be always less than 5 volt. Now I'm going to read this output voltage. This one is output voltage. So I'm going to read it in microcontroller. So our LDR is giving digital signal or analog signal. You have to answer it. LDR is giving digital signal or analog signal. So kindly respond in the chat box that LDR is giving digital signal or analog signal. I'm not able to see your chat box. Let me see where is chat box. So LDR is giving, yes, I'm getting now. Analog, very good. So LDR is giving analog signal. So we have to read analog signal value in analog pin. So which one pin is analog in the Arduino? So Arduino, the A0 to A5 pin are analog pin. So every microcontroller have their own analog pin. So some of microcontroller having more analog pin, but in Arduino there are only 5 analog pin, 6 analog pin, A0 to A5, and there is inbuilt ADC. Some of the participants were asking in the morning session that we need to connect any ADC with microcontroller Arduino. So there is inbuilt ADC in this Arduino microcontroller. That Arduino microcontroller is 8 mega 3 to 8P 8 mil series. So there is inbuilt, no need to connect extra converter or ADC. So how we have to use it? First of all, we have to take this output. This output we have to connect with Arduino. So how we can connect it? I'm just going to taking output from here and going to take it like this, and I'm going to connect this with A0 or A1. I'm going to connect with A1. So this output we have connected with this A1, ground is connected with ground, and 5 volt is connected with supply voltage. This circuit I made over here. So you can make it in a simple way also, but you have to use breadboard so that you should work in a professional way. So whenever you have to connect more circuit, you can make bigger circuit also with the help of this. Yes, PWM we will discuss each and everything we will discuss, and then we will let you know. So after connecting this, so now we have to write program that we are reading voltage. The voltage is changing from 0 to 5 volt, and now we have to read that voltage in microcontroller. So how microcontroller can read it? So I'm going in code. In the code, how you have to write a code for analog read. So you can write code in a graphical way also, or you can write code in the format of C code also. So I'm just going to show you how to write code in a graphical way if you are not having a coding background. So how to read it? For reading, you have to go to input. So I'm going in input and read. Which one we are going to read, analog or digital? We are going to read analog signal. So take it. Then after that, if you want to make serial communication mean you want to display that analog value on your computer. So how you can display that value? For that, you have to go to output, and serial print option is there. Serial print, take this block and put this block in hello world over here. Yes, so whatever value you are reading from A0 pin, that is being printed on your serial monitor. Where will be the serial monitor? Yes, I'm just going to show you how you can print it. Yes, so I'm going to start simulation over here, and after starting simulation, you can see in the serial monitor over here at the lower side. Yes, this one is serial monitor. Yes, I'm just checking the value. The value is coming random value. So this random value is coming. So why it is coming, that I want to ask, but some participant has already asked that you have used A0 pin. I want to ask from you that, but you are too much alert. That is good thing. So that if random value is coming over here, mean you have not connected any pin to A0. Connected A0. So for that, there are some shooting tips that any random value, these are error signal is coming. So if you are not going to connect any sensor to any pin and you are reading any pin, then you will get this bug value. So how to troubleshoot it? Go to pin, check your pin, you are using A1, and then again start simulation. And we started simulation. Now as simulation is being get started over here, you will get exact value over here whatever you are reading from this A0 pin. So you can see over here you are getting 6 value. Now I'm going to increase this value. Yes, and now I'm going to read also it. uh, yes, it is being read. No, I'm going to read it. Yes, now it's coming 645. So let me stop it. Let me read output voltage in multimeter also, so that I can check how much output voltage is coming and how much value I'm reading over here. Now you can see 27.7 millivolt you are reading and you are getting over here 6. Why it is so? That I'm just going to discuss. I'm going to increase it value. Yes. So now I have increased it to up to 3.0 volt we are getting, but the Arduino is reading 619. So why it is so? Serial coding part I will repeat, but can you see that why it is coming 619? Yes, ADC. So ADC is very interesting over here that in Arduino microcontroller, it is being used 10-bit ADC. So 10-bit ADC mean 2 raised to power 10. So I'm just little bit going to tell you about ADC, that which one ADC we are going to use over here. So let's come back to our breadboard. So which ADC we are going to use over here. So ADC mean 10-bit ADC 2 raised to power 10. That ADC we use in the Arduino. Mean how much it will be 1024. So this will be the total value. Mean when we are going to supply 5 volt in the Arduino, we will get output in the Arduino 1023. 1024, sorry, 1023, because it will start counting from 0 to 1023. So you will get at the output 1023. So mean if we are supplying 5 volt, you will get at the output in the Arduino, mean Arduino will read 1023. If you are supplying 0 volt, mean you are reading 0 volt, you will get 0 volt at the output. If you are giving voltage 2.5 volt, what how much output you will get? How get 512? Yes, you will get half of 1023, that will be 512. Very good. I'm going to repeat it again, that you will get, let me erase first, that you are going to use ADC, that is internal ADC, mean which convert analog signal in a digital format, because microcontroller used to read in the format of digital. So we are giving analog value to A0 pin. For that in Arduino there is 10-bit ADC we are using. Text draw, yes. Okay, sorry, I'm just erasing it. Yes, so what we are doing in Arduino, there is 10-bit ADC. 10-bit mean 2 raised to power 10. So mean 1023. 1024 total value it is. But in bit or byte, whenever we are going to read, we are considering 0 also. And we are reading 0 to 1023 total value. Mean if we are going to supply 5 volt, 0 volt, to Arduino, then we will get 0 in the Arduino. Arduino will read 0 volt. Or if we are going to supply 5 volt to the Arduino, 0 to 5 in this increasing order, our value will increase in this order 0 to 1023. Mean if we are reading 1023, mean we are reading from any sensor that is 5 volt. So we can use it, or we can convert it in again in 5 volt also if we want to print in serial monitor that is 5 volt. So how we can convert it? Just see, if we want to convert this value in a voltage signal, how we can convert? Just see, we are getting at 1023 value, we are getting at 5 volt, at 5 volt. So we are getting one number, then 5 divided by 1023. 1023. Now if we have x number in any sensor value we are reading, so we have to multiply it with x. So mean 5 divided by 1023 into whatever value we are reading. Just suppose, I'm repeating coding part also. Just suppose if x value is 1023, mean we are reading 1023, then how much output we will get using this formula? 1023 we will put over here, divided by this, we will get output at 5 volt. So I'm just going to repeat each and everything in the coding so that you will get more familiar about this ADC. Similar way we will use this ADC in output, analog output. That ADC will be little bit different, but working will be same. So I'm just going to show you practically that how it is being used in a circuit, in a coding. I'm just going to repeat complete circuit. So let's see how you have to read input. Go to input, take second block, and then go to output. In second block you have to change pin number. So which one pin you are using, you have to define that which one pin you are using for reading analog value. Then after that, go to output, and there is serial print block. So you can take this. So in serial print block, I will discuss in detail also what is serial and how we can print in a different way. So I'm just using simple block, because if you are newcomers and you are not having a technical background of C or embedded C, then you will get confused if I will discuss in detail. So I'm just using simple block so that you will get familiar about it and you can use it in a very simple manner. So over here, I'm just going to read it directly like this. Yes. This one is a simple code. Mean whatever you will read, it will directly get printed over here, and the value read Arduino in the format of 10 bit. 10 bit mean if you are giving voltage over here from sensor 0 to 5, then it will read in the format of 0 to 1023. So let's see. I have written only one block over here and two block I have used in this circuit, nothing else. So now you can see, as I'm changing voltage over here, that is input voltage, my output is changing. Output is coming in the format of 10 bit. But some participant is also get confused right now, that they want to see that exact value, whatever value we are giving to microcontroller, same value should become over here. For that, we have to use that formula that we have created over there. But now we are using one interesting function that is inbuilt in Arduino. With the help of that, we can convert without using formula. So how you can use that function? For that, go to math. So there is map function. You can note it down, map. Map is used for conversion. If we want to scale up or we want to scale down, we can do with the help of map function. So you can use map function. I think voice is audible right now. You can use map function. With the help of that, you can convert value, and you can scale up or you can scale down according to your requirement. But now what we want to convert? we want to convert this value, because this value is being read, this value is value Arduino read in the format of 10 bit. So I'm going to make a duplicate. So two block I'm having. So this block I have put it over here in the map. Which value I want to map? First this one value. And which format I want to map? Want to map 0 to 5 volt, because it read in the format of 0 to 1023. Now I want to convert it in 0 to 5 volt. So I just converted it. So if I want to print it, for that I have to use this complete block to over here in this block. I'm just repeating it again. What I did, I just went in the math, take map, in map what you want to map, the read analog value we want to map, I put it over here, and what will be the range of the output, that I took 0 to 5. And now this value we have to put over here in this block. My code is ready. Now I'm going to run it and check it out. So now let's see that what is happening right now. Now I'm just checking at the output. So now you can see over here the value is changing 1.5 to 3 something. Yes, let's see, this one is 3 volt, and you are getting exact value at the serial monitor, that is 3 volt. Now you are not getting in the point, because we are getting over here integer value. If we want to print in a point also, for that we have to take one variable. That variable should be in float, not integer. So that we will discuss in upcoming session, that what is integer, what is float, how we have to take in the programming, and how we have to use it. So just we are going to sum up today's session over here, then we will discuss in detail. So you can read any kind of resistive sensor by like this, using this voltage divider rule, and you can write program. And if you want to deploy this code in your microcontroller, then go to text. So block and text, whatever block you have created, your code is being generated over here, and this code you can use directly, copy it from over here, and you can directly paste it. So that is being done. So which class code you are asking, you can, okay, so that I will let you know later on. Okay, so you can write code over here, you can copy this code, and you can directly paste in your microcontroller. And you can also understand that this one is a math function, map function is being used over here. First I will do with this graphical, then I will also discuss this programming, that how you can learn this concept of programming and how you can implement it in your circuit. From basic to advanced we will do it, because this one part is very important whenever we are going to discuss IoT. So now we are discussing about question answer. So if you have any kind of queries, you can ask it, you can discuss it. I have shared my contact detail also earlier, so you can WhatsApp me. I'm also available in WhatsApp group. So if you face any difficulty, you can also do WhatsApp in my personal number with your name and with your college name, so that we can respond your queries more and more. If you have any query right now, you can ask. Ask one by one, there are a lot of queries. Yes, how to submit hardware assignment. For hardware assignment, what you have to do, you have to make a circuit in the Tinkercad, and you have to take a screenshot, and then you have to submit in your assignment part. Meanwhile, we are finding some solution, because for more participant it is very difficult. Yes, for YouTube, there is a link of YouTube that I shared yesterday, that is Innovate Skill e-learning. You can find over there. There are a lot of video about Tinkercad, their programming, advanced programming. over there you can also spend your time to learn more things about embedded C programming if you are beginner. And if you are want to learn advanced, there are also some advanced programming help also. There are a lot of tutorial, so you can visit on the Innovate Skill e-learning page on the YouTube. The link I'm just going to share with you so that you can subscribe over there on Innovate Skill e-learning page. I'm just going to share YouTube link. Also, we are having a page on Facebook with the name of Innovate Skill. That also you can like and subscribe so that you can get more notification about new latest projects, latest activity. We also used to share on the Facebook. Yes, I'm just going to share with you the link of Facebook, sorry, YouTube channel. So you can go over there. So where is today's kids? What kind of kids you are asking? So I have shared the link of YouTube. That is, I'm just going to share it with everyone. Yes, it is getting some. Okay. So you can visit that YouTube channel. Over there you will find lot of things over there. Yes, for mechanical engineer it's very important and very helpful, and you can learn in a very simple way. If you are belongs to civil engineering also, then also you can do a lot of practical, and you can implement IoT in civil engineering. There is huge demand in the market. So, when you talk about Industry 4.0, then there is multidisciplinary domain is required. And if you belongs to civil engineering, then it's more helpful for you. Yes, today lecture video is being recorded on the in the channel of YouTube that is being shared in WhatsApp group also. So that is fully recorded. No need to worry. You can watch it again and again if you face any difficulty during a live session. So link I will share in the WhatsApp group. So over there you can watch it. I'm just trying if I will get right now. Let me check it out if there is. Yes. So you will get. I'm just sharing link with you about channel of today live stream so that you can watch over there, and we will try to make it more interesting with the help of practical. So this one link of today live stream. So you can watch, go to this channel, and you can find two session is being recorded. So WhatsApp number, for WhatsApp number you can, I shared my contact number over here. So you can just ping me. So my number I'm going to share again over here. So you can send me a message with your name and college name so that I can add you on WhatsApp group. So this one is also chat link. You can join in WhatsApp group, but there is some limitation that participant get full. So I will add you in proper group. So thank you so much for your all participation and your very active participation, I can say. And you have joined and you have learned in a very better way. So we will see you in tomorrow's session, and we will make it more effective and more uh, interesting. So thank you so much. We will join today as per schedule. Assignment is for everyone, for civil engineer and mechanical engineer. Everyone has to do assignment. Then only you will get and you will rewarded with a certificate. So thank you so much. If you have any queries regarding joining, regarding attendance, you can ask us with Srinivasan sir as well as me, so that we can respond you as soon as possible. Thank you so much. We are going to end this session right now. Today assignment is being shared in the group in the Google classroom over there, and you have to submit your assignment accordingly. So in beginning we are giving minimum assignment, 1 or 2 assignments, so that it should not put any pressure on the participant. So no need to worry about it. So we will give you very easy assignment so that you can do it in a very simple way. Thank you so much. Hope you enjoyed this session. Thank you so much.